So let's review a little bit about graphing inequalities before we get started. First, you are going to want to use a closed dot for greater than, equal to, or less than or equal to symbols. You're going to use an open dot or an open circle for just greater than, less than. So let's practice. For x is greater than 4, you're going to go to the positive 4. Since it's just greater than, we are going to make an open circle around the 4. Now we need the arrow to go one direction or another. Since this is greater than, we're worried about the numbers that go this direction. So that's how you'd graph that. Number 2, x is less than or equal to negative 7. So first let's go to the negative 7. Since it is got the equals to sign, we are going to use a solid dot on the 7. Now where are the numbers that are less than? They go off to the left. Number 3, x is greater than or equal to negative 2. So we're going to go to the negative 2. Since it's equals to, we're going to put a solid dot. And where are the numbers that are greater than? They go off to the right. And then number 4, for x less than 11, we are going to put an open circle on the 11 and an arrow going to the left. Okay, you may not be as familiar with interval and set notation. For some of you, this may be pretty new. Set notation, interval notation and set notation is where you describe the interval or the set of numbers. So it's going to look like, for example, interval notation has two numbers, and these are the two numbers on either end of your number line. It's also going to have either a parenthesis or a bracket. You use a parenthesis whenever it is not included, or an open circle. You're going to use brackets when it's included or a closed circle. Now the exception is when you use the symbols infinity. Both positive infinity and negative infinity always have the parentheses. So it's a whole lot easier when you look at this in practice. Let's look at number 5. We're going to write this in interval notation. Now your interval is going to describe the number line, so let's start with what's right here on the left end. All right, we have negative 4, and it's a closed dot. So we're going to put a bracket and a negative 4, comma. Now what's on the right end? Well, it continues to positive infinity. So that would just be infinity with a parenthesis. All right, let's look at number 6. Look at the left end of your number line. You have the open circle with an 8. So that's going to be a parenthesis and an 8. Now what's on the other end? Well, that's your positive infinity, and we're going to use a parenthesis there. All right, number 7. What's on the left end of your number line? That's negative infinity, right? And since it's that, you always use the parenthesis. Now what's on the right side of your number line? Well, it stops at negative 1, and it's a closed circle. So you're going to put a bracket. So do you see how that just describes what you're seeing on your number line? All right, let's look at number 8. What's on the left-hand side? Negative infinity, right? So we're going to use parenthesis, negative infinity. All right, what's on the right-hand side of your line? Positive 5. And since that's an open circle, it's going to be a parenthesis. Set notation is just another way to write the solution. How do you know which one to use? Well, it's going to depend on your instructor. Whatever they ask for, that's what you need to give them. So this is how set notation is going to look. Let's say I want to write x is greater than 5 in set notation. You start with your bracket or your brace, and you're going to put x. Then there's a straight line, and then the inequality. Now the way we read this is x, that straight line stands for such that x is greater than 5. So let's just practice this down here at the bottom. All right, look at number 1. You start at the left-hand side. We're going to do interval notation first. The left-hand side is at negative infinity, so we're going to have the parenthesis and the negative infinity sign. All right, what's on the right-hand side of your bar, of your graph? The open circle over the -4. So we're going to have -4. The open circle is the parenthesis. Okay, now set notation. We're going to start with a brace or a bracket, and we're going to put x such that x. All right, now look at the graph. What is that the picture of? That is the picture of all the numbers that are less than -4 because it goes to the left. So we're going to have less than -4 and close. All right, let's look at number 2. Look first at the left-hand side of your graphed line. It's a solid dot, so we're going to have a bracket. It's at the number 3. All right, the rest of the line goes to infinity, so that's positive infinity because it's on the right, and we're going to have a parenthesis. Okay, now let's write this in set notation. We're going to start with the brace. X such that x. All right, what set of numbers is being described here? Well, it starts at 3 and it goes to the right, so those are all the numbers that are greater than 3, but since that's a solid dot, it's going to be greater than or equal to. Okay, let's look at number 3. The left-hand part of it is at negative infinity, so let's put that down. The right hand has a solid dot on -13. So we're going to have -13 with your bracket. All right, set notation is going to be x such that x. All right, since these go to the left, these are the numbers less than. And since it's a solid dot, it's less than or equal to. And what number is that? That's at -13. Okay, number 4. Look at the left-hand side. We're doing interval notation. The left-hand side has an open dot at 11. So that's going to be a parenthesis at +11. Now on the right-hand side, the arrow just continues on to infinity. So that's positive infinity. Notice that negative infinity is always on the left and positive infinity will always be on the right. All right, as far as set notation goes, we're going to start off with x such that x. Since these go to the right, we're looking at greater than. Since it's an open circle, there is no equals bar, and the number is 11. So that's what set notation is going to look like. And number 5, what's on the left is +3 with a closed circle. So we're going to have a bracket and a 3. All right, what's on the right? It continues to positive infinity, so we're going to have a parenthesis. Now let's put it in set notation. We have x such that x. All right, since it goes to the right, it's going to be greater than. And since it has a solid dot, we need greater than equal to. And the number it starts at is 3. So let's continue on with number 6. On the left-hand side, this graph begins at negative infinity. So we're going to have the parenthesis, negative infinity. Now where does it end? It ends at 10 and it has an open circle. So we'll have a parenthesis. All right, set notation is going to start with x such that x. All right, since my graph is going to the left, that's a picture of the numbers that are less than. It's an open dot, so I don't need the equals to. And the number is 10. All right, number 7. Interval notation. On the left-hand side, I have an open circle at -1. So that tells me to put a parenthesis, -1. On the right-hand side, it just continues on to infinity, so I'm going to need a parenthesis. Now, set notation. I'm going to start with my brace. It has an open circle. Let me put x such that x. All right, it goes off to the right, so those are the numbers greater than. It's an open circle, so I don't need the equal bar, and the number is at +3. Nope, the number is at -1. All right, number 8, for interval notation, it starts at negative infinity, and it continues on to -19. and that is a solid dot, so that's going to be a bracket. And then your set notation is going to be x such that x. All right, since it goes to the left, it's less than. Since it's a solid dot, it's less than or equal to, and the number is at negative 19. X such that x is less than or equal to negative 19. Okay, let's work some problems. And the only thing you have to remember is that if you multiply or divide both sides by a negative number, then you must flip the sign. That's the only thing different than it is solving just a regular equation. So here's number 9, and our instructions are to solve, to graph, and to put our answer in interval notation. So we start off here, find your variables. I have a 5v and a 7v. We need to get rid of one of them. So I'm going to subtract 5v from each side. This will leave me 1 is greater than 2v minus 17. And then we'll just add 17 to each side. I get 18 is greater than 2v. Divide both sides by 2. So 9 is greater than v. Now it helps me to have my variable on the left-hand side. So I am going to reverse this. Now when you reverse it, you have to reverse everything, including the sign. So this will now be v is less than 9. All right, to graph it, your number line there, it doesn't have any numbers. It's just got hash marks. So just pick one. Since this is less than, it is going to have an open dot. Now, which direction do the numbers that are less than 9 go? They go to the left. So this is what your graph will look like. Now, to put this in interval notation, look at the very left-hand part of your graph. What is that? Well, it's negative infinity, and infinity always has the parenthesis. All right, what is down here at the right-hand end? It's a 9, and since it's an open dot, it's also a parenthesis. And here's our number 10. So the first thing we see is a set of parentheses, and we need to get rid of it. So let's distribute what is outside of it. Now pay attention, that 3 has a minus in front of it, so it's negative. All right, this is going to give us 21x minus 15x minus 27 is greater than or equal to 7. 21x minus 15x is going to be 6x minus 27 is greater than or equal to 7. Add 27 to each side will give us 6x is greater than or equal to 34. Divide both sides by 6, and you have x is greater than or equal to, now this will reduce down, both of these will reduce by 2. So you've got 17/3. And if you want to, sometimes it's easier to graph if you change that to a mixed number. So that would be 5 2/3. Either way. All right, next we need to graph it. So go over there to your number line. It doesn't matter where you put your dot. 5 2/3 would be a little bit closer there. So just put a solid dot because this does have the equals to, and label it 17/3. All right, now if x is greater than or equal to that, it's going to go to the right. So there's what your graph is going to look like. Now let's put it in interval notation. Since this is a solid dot on the left-hand side, we're going to start with a bracket. All right, our number, the point there is 17/3, or the 5 2/3, comma. All right, what's on your other end? The positive infinity sign. So put that, and your infinity sign always has a parenthesis. So that's number 10. Okay, let's look at number 11. So first of all, we have this set of parentheses down here. Let's distribute and get rid of that. So now I'm left with 12p plus 52 is greater than negative 8 plus 4p. My next thing is I've got a 12p and a 4p. I've got to get rid of one of them. So I'm going to subtract 4p from each side. Now I have 8p plus 52 is greater than negative 8. Next is to eliminate the 52. It's been added, so to eliminate it, I'm going to subtract it. Now 8p is greater than negative 60. Divide both sides by 8, and P is greater than negative 60 divided by 8 is 7.5. So let's graph it. If we come over here, now remember on the negative side, your numbers go the other way. So here would be negative 7, here's negative 8. All right, where is negative 7.5? It's just in the middle here. Since this is just a greater than, it's an open circle. And where are the numbers that are greater than negative 7.5? Well, they're going to go off to the right. All right, now our interval notation. Look at the left-hand end of your graph. It's an open circle, so that's a parenthesis. It's at negative 7.5. Over at the right-hand end, we're going off into infinity, and that always has a parenthesis. Okay, let's work on number 12. We see this set of parentheses, first of all, that needs to be eliminated. So we're going to distribute what's outside, and what's outside is just the minus sign. So over here, we're going to have 3 minus 4m minus 1 is greater than or equal to 5m minus 25. All right, next, let's go ahead and combine 3 minus 1 right here. So that's going to give us 2 minus 4m is greater than or equal to 5m minus 25. All right, 2 variables, so let's get rid of one of them. The 4 is negative and the 5 is positive, so as always, let's get rid of the one that's negative. We can do so by adding to each side. And that's going to give us 2 is greater than or equal to 9m minus 25. So now let's add 25 to each side. So now I have 27 is greater than or equal to 9m. I'm going to divide both sides by 9. And I get 3 is greater than or equal to m. And once again, I'm going to invert those so that I'm looking at m is less than or equal to 3. Just makes it easier to graph. So let's go to our number line. Pick the hash mark you want. I'll put 1, 2, 3. All right, we're going to start at 3, and since this is a less than or equal to sign, it is going to be a solid dot. And where are the numbers that are less than 3? Well, they go to the left. So here we go. Now let's put this in interval notation. Look at the left-hand end of your graph. What's there? Negative infinity. And that takes a parenthesis. Now, what's at the right-hand end of your graph? The 3, and since it has a solid dot, we're going to put a bracket down there. Okay, let's look at number 13. We have parentheses on both sides. So let's start off by distributing. 3 times 8 is 24x minus 27 is greater than 6 times 4 is 24x plus 4. Now we have variables on both sides, so let's get rid of one of them. I'm going to subtract 24x from each side. And what I wind up with is negative 27 is greater than positive 4. Since you've eliminated all variables, what you have to do now is decide, is this a true statement or not? This is not a true statement. So the answer is no solution. There is nothing's possible. And you don't have to graph it because there's no numbers. But what if you had gotten, say, 3 is greater than 2? Well, if you get something that is a true statement, then you do have an answer, and you would graph it. Everything would be your solution, so you would graph it, coloring in the whole line both ways, and what your interval notation would look like is negative infinity, positive infinity with parentheses on either side. So if it's false, it's just the empty set. If it's true, it's going to be all solutions and both infinity symbols. Okay, let's look at number 14. First, let's get rid of parentheses. So when I distribute parentheses in here, I'm going to have 10a minus 30 minus 13a is less than or equal to 9a minus 72. All right, let's combine over here. So now I have negative 30 minus 3a is less than or equal to 9a minus 72. Now we need to get rid of one of our variable terms. I'm going to get rid of the 3a since I can do so by addition. And that's going to be negative 30 is less than or equal to 12a minus 72. Then I will add 72 to each side and get 42 is less than or equal to 12a. And then I'll divide both sides by 12. So a is 3.5. Now, once again, this is backwards to me, so I'm going to flip it, invert it. So I'll have a is greater than or equal to 3.5. So when I put this on the number line, I'll just pick two hash marks and put 3 and 4. All right, it's greater than or equal to, so it's going to be a solid dot at 3.5. And since it's greater than, it's going to go off to the right. Now, we're doing this in set notation, so we're going to have a brace. X, so, let me put A. Put whatever letters in your equation. A such that A is greater than or equal to 3.5. Okay, number 15. And we're going to get rid of the parentheses first. So let's distribute, and let's be careful because this 7 is negative. So I've got 8. Negative 7 times 2 is going to be minus 14r and minus 21, less than or equal to 3r minus 30. All right, we can combine over here. 8 and minus 21 will give us minus 13. All right, less than or equal to 3r minus 30. Next, I've got negative 14r and 3r, so let's move 14r by adding it to each side. So now I have negative 13 is less than or equal to 17r minus 30. So I'm going to add 30 to each side. And 17 is less than or equal to 17r. Divide both sides by 17. So 1 is less than or equal to r. And once again, I'm going to invert it. So that will give me r is greater than or equal to 1. All right, let's graph it. Just pick one and make it the 1. Since it's greater than or equal to, it is going to be a solid dot. Greater than goes to the right. All right, now to put this in set notation, that's just going to be your brace. R such that R is greater than or equal to 1. Close the brace. Okay, here's number 16. So first, let's get rid of the parentheses by distributing. And this will give me negative 6p minus 24 is less than. Over here, I'm going to have negative 8p minus 24. All right, next we need to get rid of one of our variable terms. Now normally, I know I get rid of the larger one if they're both negative, but this time, just to show you that it works either way, I'm going to get rid of the 6. So I'm going to add 6p to each side. Now what I have is negative 24 is less than negative 2p minus 24. All right, what's added to or subtracted from your variable term? 24. So I'm going to get rid of it by adding whatever you do to one side, you have to do to the other. Now, I have 0 is less than negative 2p. I need to get rid of the negative 2p, so I'm going to divide both sides by negative 2. This is when you have to flip your sign. I just divided both sides by a negative number. Now 0 divided by negative 2 is 0. I'm going to flip my sign and I get p. 0 is a perfectly logical answer. So next, because I do like my variable on the left, I'm going to flip the whole thing and then I'm going to graph it. So I'm just going to go to one of the hash marks and make it 0. Since this is less than, we do have an open circle. For p to be less than 0, it would have to be in this direction. Now to write this in set builder notation, you're going to put p such that p is less than 0 and close your brace. Okay, number 17. First, we need to get rid of the set of parentheses over here. So nothing on this side is going to change. And then we're just going to distribute that negative sign. So that's going to give you minus 3 plus 5x. All right, let's simplify the 6x and the 5x. So now we've got 11x minus 4 is less than or equal to 6 plus 5 is 11x minus 3. All right, now we have two variables, so we got to get rid of one of them. Subtract 11x from this side to eliminate. Subtract 11x from this side to keep it balanced. So now I have negative 4 is less than or equal to negative 3. I have no more variables, but I do have a true statement because negative 4 is less than or equal to negative 3. So since this is true, what you have is an answer of the set of all real numbers. Anything in the real number set will work. So how do you graph this? Well, like I said before, you're just going to draw a line that goes all the way from one end to the other. Now, how do you put this in set builder notation? We're going to have our variable x such that x, and we use this symbol. This means is a member of. And then your symbol for the set of all real numbers. Okay, one more. Okay, here's our last one. So we have 4 plus 5 times 2w minus 10 over negative 2 is less than w plus 7. Now, the quickest thing to do is get rid of this fraction by multiplying both sides by negative 2. And since we're multiplying both sides by negative 2, that means when we get down to this next step, we need to flip this sign. So let me go ahead and change that. Now these 2's cancel out. So what I'm going to have left here is just the 4 plus 5 times 2w minus 10. And then over here, let's just go ahead and distribute that negative 2 here. So I'm going to have negative 2w minus 14. All right, now we're just solving. Let's distribute the 5 into here. So I'm going to have 4 plus 10w minus 50 is greater than negative 2w minus 14. Combine terms here, 4 and the minus 50 will give me 10w minus 46 is greater than negative 2w minus 14. All right, next, let's eliminate one of our variable terms. We can add 2w to each side. So now I have 12w minus 46 is greater than negative 14. Let's add 46 to each side. So now I have 12w is greater than, all right, negative 14 plus 46 is positive 32. Divide both sides by 12. And w is greater than. 4 will go into both of these, so it will simplify to 8/3. All right, let's graph it. And you could just put 8/3 somewhere, or you can change it to improper fraction, which would be 2 2/3. So if you pick 2 and 3. Now since this is just greater than, it's an open circle. It goes off to the right. And now to put this in set notation is going to be, what was our variable? W, such that W is greater than 8/3, close your brace. And that is all.